Welcome to the Control Engineering webcast. Collaborative robots are now skilled welders. What's next? Sponsored by Universal Robots. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering and CFE Media and Technology. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of this webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you're having technical problems with audio or the slide presentation, click on the question mark at the top right corner of your screen to access a list of system checks to try before contacting an online technician. But if you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions box. Type questions for our speaker in the Ask a Question box on the left side of your screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You'll receive an email within a week with the link to the on-demand event. To download a certificate of completion and a PDF copy of the presentation, use the Event Resources tab on the left side of your screen. Those documents will also be available with the on-demand version of the webcast. I'm happy to introduce today's distinguished speaker. Mitch Dupont graduated from Conestoga College in Canada in 1999 with a degree in welding engineering. After spending 10 years with Panasonic Factory Automation, Mitch worked in the welding robotics group at KUKA Robotics. Currently at Universal Robots, Mitch has traveled the world, including North America, Mexico, India, Germany, and Denmark, installing and implementing welding automation. His experience ranges from installation, service and sales of welding automation and high production automation environments to simple pre-engineered cells at small and medium-sized businesses. Mitch is passionate about welding and all the opportunities it provides to small and medium-sized companies looking to automate their high-mix, low-volume production with a solution that's never existed before, the collaborative welding tool. Mitch, please go ahead.
Thank you, Mark. I appreciate everybody who's joined in on this webcast to listen in, and I hope that this will be as informative as I think it is to the marketplace. So I'm typically used to doing these presentations live and looking at the audience reaction, and in this case it's a little different. It's my first webcast, so bear with me as we will go through this. So yeah, according to my bio, I have about 20 years of experience in automating the welding process. Started with a robotics company right out of college. Enjoyed it immensely. Like I said, traveled the world, been in many different plants, seeing the welding process automated. Everything from extremely high volume type applications in automotive and tier 1 down through job shops. And there's been great successes in automating welding down through the whole industry and the market, but there's also been barriers to entry. I'm enjoying greatly working here at Universal Robots as we're able to get down and automate in areas where, and in manufacturers that haven't been able to take advantage of it. So let's get started. The agenda for today's webcast is going to be an industry introduction in welding robotics in general, robots being used in welding, and down into who's been using it and who's been successful using automating the welding process, and then moving into the cobotic product and who can take advantage of it and who it's for, and then what that customer profile would look like. So with the industry introduction, I like to use this graphic. I've used it internally and I use it externally with individuals and companies to discuss it. And I use it kind of as a triangle, starting at the top. Actually, you know what? We'll start at the bottom. And with manual welding, there are certain certified welding processes that just will never be automated. Think welding underwater would be one of them that would be very difficult to automate, as well as in-field welding such as, pipe industry or oil and gas and things of that nature. If you go up to the top of the triangle where it says sophisticated users, this is a part of the market that has been able to take advantage of welding automation successfully and has tremendous success in it. You're going to see some companies or industries labeled there that are going to make complete sense. Tier 1 automotive, these are high volume part manufacturers making hundreds of thousands of parts and to supply the automotive industry. But off to the left, you'll see a small little triangle that says heavy plate. And these are manufacturers like the picture shows that would be doing very large weldments, mining equipment, a lot of ag, forestry equipment. And there's certain characteristics of that type of weld, and we'll discuss a few of them in the coming slides. And then we have underneath that, what's labeled there is Universal Robots Target Market. This market would be largely unsophisticated robot users. They generally don't have any robots in their facilities right now. They do a lot of things manually. Low volume, high mix would be a characteristic of these type manufacturers. And so that's who we would target with our product, and we're going to go through the reasons why. Kind of in between that, we have pre-engineered systems. These are systems that traditional robot companies have manufactured. They pre-engineer them, you buy them, they have very specific characteristics. So this kind of makes up the welding market from a robot manufacturer's perspective, and I think that's important for those that are on this webcast to understand, is that this is how a robot company is going to look at the market. And the robot companies, as they approach this market, create their strategies on attacking these markets based upon how they view it. It may seem obvious, but when you look at the kind of products that they've developed and what they've done, it very much reflects this top of the triangle. And in going after that, and I'll give you an example, because this example hopefully will make sense. A tier 1 manufacturer in the automotive industry may buy 469 robots for one project. It takes about the same amount of effort for a robot company to win that business as it does for them to sell 10 robots to 10 individual users, give or take a little bit of effort. So the robot companies will develop their strategies around winning, for instance, tier 1 business. For the same amount of people in resource output, they can sell a lot more robots. Obviously, margins are low, but they like their margins up in other areas. And so a lot of the technology that they developed, the robot development, is all based upon this kind of strategy. And so that has created, if you will, barriers, both certain things that have been successful for those users have also become barriers to the target market and the low volume, high mix type applications. So let's go on. So into the next slide. So let's talk about that traditional automation. What does it mean when these companies have developed their sales strategies and their products around going after these higher volume type opportunities? Well, what it has meant is to try and capture, there's some pictures that are going to come up here in the future in a video and stuff, but to capture a little bit of that low volume or high mix type job shop, they've done these pre-engineered systems. And in developing these pre-engineered systems, though, they still have a limited work envelope. And it still very much is the fact that the production will revolve around the automation. And we're going to discuss this a little bit more in the future here. But the big thing for both the tier 1s, the heavy plate, large part manufacturers, and the job shop type shops that are buying the pre-engineered systems is they have to justify the purchase of it through utilization, calculating utilization. And so what that will basically mean is if you have high volume number of parts per hour, then right away the salesperson is going to ask you how many parts do you need to make. what's your cycle time on those parts? And what they're really looking for is, what is your utilization ratio going to be for your robot? Are you going to be using it 10% of the time, 20% of the time, or do you have a 2-shift operation? And once they see that utilization based upon the volume of parts go up high enough, then they realize that you're a customer that could utilize automation. Or in the heavy plate world, it won't necessarily be parts per hour or cycle time that they care about, but it'll be deposition rate. How long is this robot going to be welding? This robot's arc on is going to be on for 3 hours to make a part. It's going to take 4 hours to make a part. You might only make 2 or 3 a shift, but the robot's going to be working, making money, and they calculate every time the arc is on, that's when the company's making money. That's how they will justify it based upon the utilization. So what we're going to do here is we're going to watch a video which this gentleman, who's the COO of the company, is going to be discussing a cell that they have purchased, a pre-engineered cell, and then discussing a cobotic welding offering and contrasting the difference between the two and what his business model needs to look like based upon whether he's buying one of these pre-engineered traditional welding systems or buying this flexible cobotic welding system. And then we'll go through a little bit more diving into the traditional welding automation. So you can start the video now. All right, I'm standing here with Eric Larson, right?
That's right.
Eric Larson from TMI. What's your title?
Vice President of Operations.
Vice President of Operations. All right. So I'm just picking Eric's brain here a little bit. So we're going to put this on video now and walk over. But we're going to contrast a little bit about, they have a semi-flexible cell called pre-engineered system over here we're going to talk about and contrast that against what we're doing over here with the new high robotic cell. So thanks for taking the time, Eric. I really appreciate it.
You're welcome.
So why don't we walk over to the Fixturing cell and we'll discuss a little bit about what you did there. All right, Eric. So talk to me a little bit about this cell and your experience here with it.
We put this cell in a number of years ago for 2 product lines that we were doing that were very large run product lines. So we actually, on this robot, there's 4 stations, so we could run the parts, four parts on here and never stop the welding process. But we found it was only good on a large run product. And most of our products now are short run, small run, 50, 100, maybe up to 5,000 parts a year, but that only equates to, a few hundred a month. So we don't use this. It sat vacant for a couple of years, and then we got a company that came to us and wanted us to do a part, which was a high volume part. They had a lot of parts to go into the part. So we had a fixture made, which was very expensive, $25,000 for a fixture, to ensure that all the components of the parts are in the proper space and all the welds get put in the right spot. But right now, that's the only large, high volume parts that we do. So,
but on definition of high volume, how often do you run this cell per week?
Right now, they've slowed down because of the time of year, but we'll run this when we get more in the spring. We'll get up to running both two shifts a week, so 80 hours.
Okay, so 2 shifts every day per week on this cell. Yep. And so let's talk a little bit about this tooling. Did you guys buy and build this tooling?
We had somebody design and build the tooling, and it's owned by the customer who we do parts for.
Okay. So you don't own the tooling, the customer owns the tooling. Is there a particular reason for that?
Because of the expense. We would have had to have added the cost of the fixturing to their part. And instead of doing that, they said they'd buy the fixture, so then if they wanted to pull the fixture back, they could have the fixture.
Okay.
And we didn't have the extra capital invested in it.
Right. Makes sense. So roughly, what would the price of a fixture like this be?
This one was $25,000.
$25,000. So you have a part that you run, you have a certain time of the year, this cell isn't running right now, maybe once a week, but on the peak times, now how much of a year would that be? Like half the year, 3/4 of the year you would run 2 shifts?
I think it was like 4 months we were running constantly on it.
Okay, so 4 months out of the year you run constantly, the rest of the year you're maybe running with 1 shift a week or something like that to make up the parts. Okay, and $25,000 tooling. So again, this is not a case that these systems don't work.
No, it's a great system, but you got to have long run parts.
Got to have long run parts.
You can't afford to build fixturing for short run parts. It's just not cost effective.
Okay.
I mean, when you're doing short run small parts, you're talking pennies, dollars compared to another customer. So you really have to whittle down that quote price in order to get the part in the door, and that doesn't usually include a fixture for it. So.
Right. Okay. So contrast that then to what you guys are seeing, some of the benefits and capabilities of like the Cobot based welding system that you have over there.
On the new robots over there, the table is the fixture.
Do you mind if we walk over and we can talk while we're...
As you can see, we have two cells set up, a double table and a single table. The double table acts more like the cell we were in, where you can be welding a part while setting the part up. This is the second robot we got in. We asked Robotics to do this for us so we could do a double cell on it. That way it's always welding when the operator's putting another part on the bed. The first one over here, where we have the part actually fixtured in, you can see the fixture. So it comes with all the clamping. So you can take your part and you can figure out how to set your part up where we use the clamps to hold your part in place. It's all based on pin locations of holes. So after we get a part located like this, we'll take a picture of it and we'll document the hole locations and what clamps we use. So then down the road in a week or two, when we have to do this part again, we go back to the picture, we go back to the setup sheet, and we can set up the exact same way. So the program that's in there will weld it the exact same way.
All right. All right. Sounds good. Thank you for the time, Eric. It's a pleasure. So this is, again, this is Fixturing here at PMI. They are shooting a case study video here, but I'm taking all these little clips, so I really appreciate the time, Eric. You're welcome. All right. All right. Thank you for watching that. A couple of things I'd like you to pull out of that video. Number one is the inflexibility of the tooling on the traditional automation system. And number two, the cost of the tooling on the traditional automation system. Oops. And there we go. So, and I want to contrast that a little bit as we go through the traditional automation. We're going to talk about high volume type production right now, and then contrast that with what you would have seen there with the cobotic systems and the flexible type tooling. So in traditional welding automation, cycle time is the key. This translates into fastest robot wins. I've been involved in head-to-head competitions where the decision on which robot they'll go into comes down to 0.1 of a second. Simple math will show you when you're doing 500,000 of a part that has a 30-second cycle time. If you can save them 0.1 second either on every weld or every part, that translates into hundreds to thousands of parts extra that they produce at the end of every year. So cycle time really is the key in high volume production. And so because of that, the robots are caged. They have to be installed in an environment where they are locked out from operators or anybody's, even like area scanners can't even be used, because if people walk up to the area scanner and it causes the robot to slow down, that affects their cycle time. And they have these parts down to the fraction of a penny in terms of profitability. They need to manage all of those things. So the robots are locked out. No human is allowed to interact with them. This guarantees a specific rate of production and enables the robots to move at their maximum speeds. Now, what this also means is that the manufacturing of these companies now begins to rotate around their automation. So this, if a company, as this is an example of a truck frame being manufactured, this whole plant will have been designed from ground up to do this one product. But if you're a company that's just adding automation in for the first time, With traditional automation, what will happen is all your production now, all your conversations around your production will begin to rotate around the axes of this new cell, this new automated cell that you're bringing in, how your material flows into your plant, how it gets processed and where it gets processed, how it's presented to the cell, and then how the products that are coming off the traditional automation are then sent down the line either for post-welding cleanup or painting or whatever else processing that needs to be done. And so this actually causes, and generally, whole automation departments to be started. I'll give you a story as an example. When I worked at Panasonic for 10 years, I did all the installations for them all across Canada, US, down into Mexico. And we had one customer that was a tier 2 supplier, and he bought a number of Panasonic cells and was manufacturing products. And I did all the training for Panasonic, and he sent a number of people for training. And he kind of came to me one time and complained. And his complaint was, I keep hiring people that have Panasonic on their resume, but they turn out not to be very good. And my comment to him was, well, I'll give you a piece of advice. And he said, what's that? I said, forget that they have Panasonic on their resume. Look for manufacturing experience. The important factor here wasn't that they knew the robot. The important factor was they knew how to manufacture product. And they had worked with automation before and knew how to set up manufacturing in a plant for automation. And so that's what he did. And he ended up hiring some people with some FANUC and some Motoman background, not Panasonic, and was extremely happy with them because they knew wiring, they knew PLCs, they knew safety, they knew all the other factors around implementing automation and keeping it running successfully for manufacturing. And so in traditional welding automation, that automation becomes the literal focal point or axis upon which the whole plant and all the production begins to rotate. One of the things you can see here in, and I'm using this truck frame as an example because this is the extreme example of high volume type production with a lot of welding on it. And one of the things that you can see on this is that there's a lot of components that go into this final assembly, as they call it, this final frame. And many of these components, there's more than one. There might be two, a right hand and a left hand, or they need 2 or 3 cross members to go in. So they'll have a final assembly fixture where they put all this together and weld it together. But they also need sub-assemblies to put this together. And these sub-assemblies also need manufacturing cells. So the slide before this one showed one station in a whole line that would be put together to manufacture the final frame. But outside of that manufacturing line, they will need sub-assembly cells to make the subcomponents that go on to that final product. Now, why is this important? It's important because it's not just the cost of automating that final frame. It's the cost of automating all the sub-assemblies that need the same level of accuracy and quality coming out of it. And so a lot of companies will not have the volume or will not have the profit margin in the product that they're selling to their end customer to be able to automate both the sub-assemblies and the final assemblies to put together a final product for the customer. And so they still are forced to do it manually, even though the equipment they have processing the parts that need to get welded together, create quality parts of a high enough quality that they could automate. They just can't justify the overall cost because, as you saw in that video, they have to spend $25,000 not just for the final assembly tooling, but also buying a cell and paying up to $25,000 or more just for the tooling to make the sub-assemblies as well. And it costs them out, and so they wind up still manually welding them because they don't have the volume needed to justify that level of automation. Then you get into large part manufacturing, and large part manufacturing has, it's actually justified the same way to automate, which is through utilization, but a slightly different calculation. What we've talked about up until this time is volume of parts. This will be on deposition rate, arc on time, how many pounds of wire the robot is able to place on the part in a given period of time. And it requires also a lot of other technologies to go into it. A lot of times these parts are not as accurate, as an example, as the high volume type parts. And so they need added technologies to the robot, such as through arc seam tracking, TAST, touch sensing, or laser seam finding or tracking as technologies added to the robot to ensure that they're able to complete a quality part. And this gets into the other major point and the major reason that many manufacturers are looking at and interested in even the cobotic solution and are still trying to implement traditional welding automation, though unsuccessfully, in certain manufacturers. And that is because they can't find people. And so you need, if you were going to weld these large parts by hand, you would need highly qualified and skilled welders. They can't find them. AWS estimates that by 2022, I believe, there's going to be a shortage of 400,000 welders in the U.S. alone. And so manufacturers are already feeling the pinch of finding qualified welders. And so they're trying to automate. What you get into when you get into this large part manufacturing is, in many cases, one of the reasons they're having trouble finding welders is because maybe the company is remotely located. It's not located in Michigan, where there's a plethora of welders and a ton of robotic technicians available for hire. They're actually located in Wisconsin or somewhere like that, where they don't have a large pool of talented resources to draw from. Very, very talented people there, just not the volume that they need. And so they can't find welders. And if they implement traditional automation to weld up large parts, now they need highly trained and sophisticated robot programmers that know how to use not just program the robot, but also know how to use the technologies that need to be added to the robot to be successful, like through arc seam tracking, touch sensing, laser finding, and tracking. And for those that are aware of these type of technologies, know that the knowledge of the operator goes up exponentially as they add these different technologies to the systems. Then you can get into situations where you might have two robots working on the same part, and then you have part manipulation. The part has to be churned, and so you get into things like coordinated motion. And all this speaks to, you need very, very knowledgeable operators to be able to, and robot programmers to be able to keep systems like this running. So typically in my presentation, I would give the opportunity for people to ask questions now onto what we covered up until this point in time, and we can engage in a back and forth. Unfortunately, in a webinar, I don't have that ability. So what I'd ask you to do is jot down your questions, type them in the question field, and submit them. And at the end of the presentation, I will cover as many of them as I can in the time allowed. But what I would like to do now is move on to the cobotic welding automation. And there's a couple of things that I would like to cover. So many of the things that have made traditional automation successful, and I want to be clear that traditional automating welding traditionally has not been a failure. It has been a massive success for a narrow group of companies that qualified for that automation. The same things that qualified them for the automation were the barriers of entry to a lot of other manufacturers who couldn't get into it. They either didn't have the volume, they didn't have the skill set of people, or they didn't have the profitability in each part that they were making to justify automating. And so right away, they did not qualify. They could not be part of the group that was able to take advantage of automating. And it has been tried and tried many times to provide solutions to these companies. But I will say that in general, not very successfully. The barrier of entry for many welding manufacturers was very high. They couldn't get over the barriers of entry to justify automating. And many companies even invested in certain welding automation in cells, only to find them utilized for a short period of time or not utilized enough, or the struggle to keep it running and finding people that could keep it running. So if you remember the video that we watched, the CEO of the company, Eric Larson, talking about that cell, he's saying that 4 months out of the year, they run that 2 shifts a day. And the rest of the year, 2/3 of the year, they don't run it at all. Or they run it one shift a week, I believe is what he said. And this is typical. That's very typical a lot of times. And sometimes the company can justify that. A lot of companies can't. But at the same time, Eric Larson didn't talk about it in that video, but in other cases, he's sat down and said they can't find welders as well. So they turn down work and don't quote work because they know that if they won the work, they couldn't hire enough people to be able to complete the work, and they don't want to do that to their customers. And so enter the Cobotic welding automation solution. It's a far smaller footprint than what you saw for the same work envelope, same size parts that could be welded. The system actually has a very small footprint. And there's basically 2 factors that determine whether a Cobotic application or the Cobotic solution will work for the customer. For it to work for these, what we refer to as the low volume, high mix manufacturers, these manufacturers that need to change over quickly and they can't vary the cost of the automation into 1 part or 2 parts, but it has to be syndicated out over a number of parts. For them to be successful, there's 2 hurdles they need to overcome. And those would be, they'd have to be able to fixture the part quickly for small batch runs. And number 2, they have to be able to program that part, put the program in so it can be welded very quickly. Basically, if the time it takes you to fixture and program the part is greater than the time it would take the manual guys to weld it, it's still not justified, regardless of whether it's a cobot welder or a traditional automation system. And so those 2 hurdles have to be overcome for it to be successful. I'm happy to say that the Cobotic system has overcome those hurdles. And so now this enables those manufacturers to still enjoy all of the benefits that traditional automation companies that have been successful with traditional welding automation have enjoyed. They now get to enjoy it, but on their low volume, small batch runs. And so they can increase their quality. They can get accurate production estimates, precise control over consumable utilization, and accurate profit estimation. I can tell you that in the Tier 1 automotive industry, like the pictures of the frame manufacturing that I showed you, they're down to fractions of a penny to win business. The profit margins in the Tier 1 automotive business are so slim. But I can tell you that even Eric referenced it in his video. So they're more of a job shop, or at least their orders are small batch orders that they get in from their customers. He's still talking about down to pennies also, and just a few dollars in profit to be able to win the business. So they have to be very accurate. Even small job shops still have to be very accurate when they go out and they quote business to win it. And this now affords them the ability to be accurate. They don't have the variability that exists in manual welding. And so that precise control over consumable utilization is very important to that. And so they can get accurate profit estimations for their business. So what we're going to look at now is a system overview video. This is the gentleman on the floor who runs the systems, talking about the benefits of the system, and you will see him address the 2 things that I've talked about: the speed at which he can fixture the parts, and how quickly it took him to learn how to program the part. So you can start that video now.
All right, I'm here with Sean from PMI. Sean, you're running some parts here. What are you doing?
Yeah, I got an order of 51 parts I got to run. I've set it up pretty easily with the tooling that was provided. It was pretty quick, and it's pretty quick to set up. I'm ready to rock out with 51 parts.
Okay, so these are your 51 parts that you're running today, right?
Yep.
Okay, so we've got 51 parts here that you're running.
Use all the side components to the part. My other pallet's sitting across the shop. And yeah.
All right, so low batch production, you got an order for 51 parts. So tell me a little bit about the tooling here. What is this tooling that you're using here on the plate, and how does this work?
The tooling here, it's kind of like playing with Legos or
The connects? Yeah. You know the connect stuff?
Yeah, that's exactly what I was trying to word. Yeah, it's kind of like playing with connects. This tooling is. It's kind of fun to jig things up, and it's.
So you have these quick pins or whatever that you put in, then you have these like angle brackets and everything that you arrange to fixture the part.
Yep.
So you guys, in case you didn't see on any of the other videos, they have quite the fab shop down all up in here. So they have CNC brakes and punch presses and everything else. They have high quality parts coming in, and they have modular tooling here that they can put together really fast. And then so you can do small batch runs like 50 parts quickly. So how much time would you estimate it takes to set up something like this?
The whole setup, maybe an hour, and that's because I'm still new with the system.
So it took you an hour to set up, and you can run 51 parts after that?
Yep.
How long did it take you to learn to program the robot system?
When it first came in, about a half hour.
What? Had you ever used it before?
No.
You never used the system before, and in a half hour you were able to program?
Yep. It's fairly easy. It's user friendly. Yeah, it does not take long to learn how to operate one of these.
Well, Sean, thank you very much.
Not a
That's
problem.
awesome information. So, yeah. So, again, Mitch, we're here. We're going to do a case study, but I noticed what these guys were doing, and I thought, you know, a little quick clip for you guys to kind of get an idea of what we're doing here with the collaborative robotic welding. See you guys later. All right. Hopefully you enjoyed that video. A couple of things in there. You saw the tooling and what they're using there. And the other thing, to address the ease of programming, you watched him walk around the cell, take the robot, he pressed the button, and he just moved the robot out of the way so he could get the part out. To contrast that, for anybody that's on this webcast that either hasn't programmed a robot or you know, just doesn't have that kind of teach pen in your hand experience, even for I had 20 years of experience, even for an individual that has tons of years of experience on a teach pennant, they would have had to have picked up a robot teach pennant, figured out what movement system they were in, Cartesian tool world, figured out which way to push the button, move to get to physically move the robot out of the way. That would have been, for the best of the best, a 30-second job. For most people, probably taking them a minute and a half. Doesn't sound like a lot of time, but when you watched him do it, he did it in about 2 seconds, 2 to 3 seconds. And that's the difference of the time factor. If you can program a robot in that methodology, you're gonna be able to create programs far faster than you are with the traditional programming method. And so one of the things that was in this in that video that you could see in both videos actually, and talked about quite a bit in the first video, was the flexible fixturing. One of the keys to this is you still have to have accurate and good fixturing. The robot's still going to go to the same place once you create the program every time, and but you need to be able to fixture the part quickly. And so with these flexible and modular tooling systems, you can greatly reduce the time to fixture the part from one to the other. The tooling is not dedicated to a specific part, but is modular and able to be conformed to your part. And what you heard Eric say in the first video was what they do is they take a picture so they could know where the layout of the holes are, and if they ever have to do that part again, another 50 run batch of those parts, they'll know exactly what where to put the various components of the fixture in place so that they can just hit start and run that part again. So this modular tooling really makes a difference in terms of programming the part. The other thing I do want to say, though, because I think that it is important for everybody to understand, is if you notice that I pointed down their fab shop, you still need quality parts coming in. If you're a manufacturer and you're on this webcast and you have your 10-year-old son or daughter with a tape measure chopping bar stock off with a bandsaw, you're probably still going to have some struggles. But if you have quality processing equipment, processing the parts that are going to go into the final assembly or the sub-assemblies, and you have quality modular fixturing and tooling, you can fixture up parts very, very quickly. Fast programming. I talked about it a little bit when I talked about Sean pushing the button on the robot and moving it out of the way. But the ability to teach a program very quickly is the second important factor in ensuring success of cobotic welding or success of automating small batch, low volume production. And so from Sean's own mouth, I'd not asked him that question before, from the time he saw the robot for the first time to where he could create a program and make a part was 30 minutes. And I want to also make clear with traditional automation, typically when you purchase that, you're usually negotiating, and most companies will throw in, 1 seat of training. What that means is that's about anywhere between $1,500 and a $3,000 course. It usually lasts about a week that you would have to take your person off the shop floor, send them into that training class to get trained on just how to make a basic program with the robot. And then typically there's secondary training classes that they'll have to go to, again, ranging from $1,500 to $3,000 to learn to use all the special software that you will load on your robot. As an example, you'll need extra training specific to welding, the welding software. You'll need extra training specific to if you have touch sensing, through seam tracking, laser tracking. Any of those software features require extra training and knowledge. So not only do you have to take your individual who's being trained off your floor and they're not being productive on your floor, they're now getting trained and you're educating them. Hopefully they're dedicated and stay at your company. In a lot of cases, they end up finding out that they're now marketable on the street, and companies complain about turnover of employees. And so all of these things come into play. If you can take an individual and in 30 minutes bring them in off the street and they can be making a program on your robot and programming parts, and you can teach them how to use the modular tooling, and now you have a winning combination that kind of shifts the power back a little bit more to the manufacturer due to the fact of the labor market and that you can't find people. The other point that I'll make here is, and I made it earlier, but I'll make it again here, partially because I have it listed in my slide. If you can weld them up manually faster than you're able to fixture them and program them, it makes it difficult to justify. But if you can have one person now manning 3 systems or 2 systems, going back and forth between the 2, producing your small batch parts, able to program and fixture them quickly, now you've augmented your labor. Other videos that I haven't included in this presentation, but Eric will talk about how it's not a matter that he doesn't want to hire people at all. That's not the case. He would hire as many welders as he could find, but he can't find them. So he's augmenting his labor, making that one welder or the 2 welders that he has hired far more productive by simply having them man these type of automation cells where he needs their welding knowledge, not robot programming knowledge. And now the company is able to go out and bid on and win more business, making that company more secure for the future and all the other employees working there. And now those companies who traditionally haven't qualified for that automation, for welding automation, now can automate. They get all the benefits that all the companies that have automated in the past enjoy. And so high volume manufacturers, people have said to me, I disagree with it, but they don't make cars like they used to. Well, no, they don't make cars like they used to. I'm kind of happy that they don't make them like they used to. They're far more reliable and of far higher quality than they ever were in the past. And a lot of that comes from automating the manufacturing processes of building automobiles. And so tolerances are much tighter. and quality is much higher. And so this particular company in these videos that you watched make parts for fire trucks. So typically, fire trucks aren't going to be super high volume, but I would think that we would all want high quality fire trucks so that when they pull up to put the fire out in your house, it actually works and doesn't break down on them. And so enabling these companies to enjoy the same levels of quality that these high volume manufacturers or giant, Caterpillar and New Holland and these companies that have a lot of welding get to enjoy, and pushing that down lower into manufacturers that maybe are doing smaller volume, makes higher quality products available to to all of us that we would enjoy. And so, as I had alluded to before, you get a higher quality, but it also enables these companies to be far more predictable when they're out quoting business, giving them a better opportunity to land business that maybe they couldn't land before, because they have far more control over consumables, what their production estimates will be. They can become far more accurate. They know how many parts they're going to produce in a day, and so they'll know exactly how long it takes to make those 50 parts that they need to make. And so that also enables them to better predict what the profitability of that company is going to be at the end of a quarter or a year. And that also ensures the greater management of resources. Overwelding is a big deal. And if you overweld even by a fraction, the amount of extra welding wire that you're using, shielding gas that you're using, and electricity that you're using is exponentially greater. And so by being able to automate, we can better control many of the resources used to use those, both environmental resources. There's environmental impact producing welding wire, producing shielding gas and electricity, but also the resources in the company itself as they manufacture and make those parts. So let's look at what a typical customer profile would be. If you haven't guessed yet, low to medium volume part production, there's a lot of companies that will be able that fit that category, far more of those actually than probably in the high volume production. Companies that need high flexibility in production, take the automation to where the production is being done. So as I alluded to earlier, companies that buy these traditional automation cells, like the one that was in that video, they plunk it down in a certain part of the shop. And yes, I know that the robot manufacturers and the welder manufacturers that sell these pre-engineered systems even will say, well, you can pick it up with a forklift, move it around your shop. Nobody does that, just in case you're wondering. They put it somewhere, they wire their three-phase power there, they put their welding gas on it, their shielding gas on it, they add their wire and they start welding, and that's generally where it'll stay. Not saying that nobody's ever moved them around, but it doesn't typically happen that often. However, with a cobot robot that you can pick up by hand and move, you can actually bring production to where you can bring the automation to where the production is being done, potentially. And then if the nature of your manufacturing doesn't allow you to reorientate your manufacturing around an automated cell, what you want to do is insert automation into your current way of doing production. This is the best way to do it. And then I talked about earlier, I allude to it again, you can't find welders, you can't find people. Companies that are struggling with a labor shortage. And then companies that are not going to purchase hundreds of robots at a time, right? So these will be companies, most of the companies that will utilize something like this will be companies that will only ever buy one or two. They don't need hundreds of robots. They might only need 2, 3 of them to augment their current labor. Now, what I will say, it's not on this slide, but what I will say is there has been a tremendous amount of interest, though, also in those sophisticated robot users in the cobotic system. Many of those manufacturers, especially the ones like in the ag industry and in the mining industry, building these large things, also see great benefits even in their production to insert this where necessary. So again, not being able to see everybody that's on this webcast, I'm going to make an assumption that there are probably those companies represented here as well who actually look at this and say, yeah, we're sophisticated. We have a lot of people that really know automation. And that's partially why we're interested in this, because we see some of the same benefits being able to be utilized on our shop floors as well. And so it's not just necessarily low volume part production. In some cases, this also can benefit those that have traditional automation. So they have whole departments, they have tons of traditional automation going on, but they can almost use as many of these kind of cobotic flexible cells and robots as they actually need for traditional automation. All right, next slide. I think I'm running down a little bit short on time here, but this is my thank you. So the title of this presentation was "Collaborative Robots Are Now Skilled Welders. What's Next?" So if I can get on a little soapbox or wax eloquently here for a second, we all, I think, like to talk about sending robots to Mars, opening up a capsule. The next thing you know, we have robots mining minerals for us on Mars, and you know, all of this kind of stuff. But at the end of the day, what I think the vast majority of people out there want to know that their job is secure. They want to know that that the work that they're doing is contributing. And you know, in my opinion, okay, that's what's next. There's nothing amazing about this outside of the fact that if you're in this industry like I have been and you've traveled around, you have seen so much manufacturing that can utilize a product like this. And through Espen's brilliant mind coming up with, you know, a UR collaborative robot, has opened up a world that didn't exist before for a whole group of manufacturers. And that's what excites me. What's next for me is seeing a revolution in manufacturing that is quite significantly different than what we have seen before. If I can put a plug in, even come to FabTech 2019 if you want to get hands-on some of these products and processes, because I think that we're going to see a radical change in manufacturing and what manufacturing floors look like into the future. So I appreciate your time. So I think that I think it's now time to field questions. So I'm thinking here, Mark, that you're going to come on and we're going to take a look at some of the questions.
Great. Thank you so much, Mitch, for your presentation, the videos, and advice. We do have time for some questions. The audience may type questions for the presenter in the Ask a Question box on the screen, and we'll get to as many as time allows. Questions that we don't get to today will be posted online at controleng.com with the archived version of this webcast. Please remember to download a certificate of completion or a copy of the presentation by using the Event Resources tab on the left side of the screen. And now we'll get on to the question and answers. How do you address the safety compliance issue with respect to collaborative robots on the plant floor? Their environmental health and safety manager is asking to set a perimeter around a robot, even though he was aware that it is a collaborative robot.
Yeah, so I don't laugh because I think it's a dumb question. Please don't interpret it that way. I laugh because I figured it was going to be the first question that was going to be asked. So as it relates to safety, we are doing some safety assessments now with third-party approved companies to give direct direction to companies on how to handle safety. So as with all automation, a risk assessment always has to be done. So I say that. There is a safety specification for collaborative robots. So what I do is I make a distinction between two things when I talk to companies about this. And the distinction I make is this. There is a collaborative safety spec around the robot arm itself. So forget what the robot's doing and just say if you put the robot into torque and speed limited mode, it meets the collaborative specification. And so once that's accepted, then really the second question becomes, and so what that would mean, sorry to go back to that first point, what that would mean is you would need a collaborative capable industrial robot. You want to buy an industrial robot, something that's designed, has a track record and a history of being reliable in the field. And then from there, you want to make sure that robot has the ability to be collaborative capable. Okay, so universal robots are both of those things. And so then you move on to the application. And this is where the question usually arises when we start talking about arc welding, because the question is the application itself qualify as collaborative. Now, the example that I give is this. If you have a collaborative robot, you put it in collaborative mode, the robot itself is collaborative, but now you duct tape a razor blade on the end of it because you want that robot to cut leather or something. It's not collaborative. There's very little you're going to be able to do to make that collaborative unless you put barriers up so people can't get in, same as you would do with traditional automation, so they can't get into any kind of danger zone. You can do that barrier through light screens, gates, doors, whatever. Or the specification does allow for proper PPE. Now, in the example that I gave with the razor blade, that's going to be difficult to do unless you design a suit or something like that you can prove and get certified that there's no way that razor blade could cut through it, but still has the dexterity for the operator to do what they want to do. In theory, you could do that and then have the operator actually interact with the robot. So the question kind of on the table here is welding a collaborative application? And my immediate answer to that is, well, no. If you're going to decide that you're going to put on a bikini or a Speedo and go and program that robot and have it weld beside you, that's like frying bacon with your shirt off. It's kind of dumb, and obviously you're going to get hurt. You're going to get burned from the arc flash. You're going to get burned from the spatter. Pretty dumb. You'll probably go blind as well. However, the question is on the table, and this is why we have a third-party company coming in: leather gloves, leather safety jacket, proper pants, steel-toed boots, welding helmet, and safety glasses. I think I covered it all. Does that make it collaborative? And that's within reason the question on the table. However, this is the final thought that I'm going to leave in relation to this question around safety, and that is this. The most benefit that comes from this is the ease of programming and the flexibility of tooling to be able to tool the parts. In reality, once you hit go on that robot to weld the part, just like a manual welder, you'll still need arc flash shields and everything around it, but you're now applying automation to a low volume part. And so if at the end of the day, the cell needs an area scanner and flash screens, put an area scanner and flash screens around it. You still gain the benefits of the fact that you can tool a part very quickly and you can program it very quickly, and you don't need massive amounts of training and everything for the individual that you bring in off the street or you promote up within your company to operate that machine. You still get all the benefits, even if you do need an area scanner around it. You will always need flash screens, no question there, but even if you need an area scanner or some sort of barrier. So that's my answer to the question of safety.
Great,
is there another
thanks.
question?
Here's a question on the robotic welding. If the robots are locked out, how do you catch welding issues in time to reduce the product quality issues?
There's multiple ways that you can do this. So I mean, very rarely, but some people put external cameras in so they can see, but that's very rarely done. I've only ever seen that done once or twice. Typically, you're monitoring a part when it comes off, and you're seeing variability there. So if it's a weld-off location, then you would see that on one part, and if you consistently see it, then you'll have to go in and address it because it's either a robot programming issue or a part placement issue. And then a qualified welder, if somebody that you have running the cell is actually a welder, they can hear by sound. If they run out of shielding gas, they run out of wire, things of that nature. So, if they run out of wire, they're gonna the robot will stop. And then part and parcel with that is the kind of welders that you won't wind up hooking up to the robot. So the robot can interface to pretty much any welder out there, and even within a certain brand of welder, the different types of welders. I'll use an example of Miller. Miller has an auto continuum, which is designed specifically for automation, but then they have XMT welders and lower welders that are designed for manual welding. Well, you can hook up any one of those welders to the solutions that we have available through our partners, okay? But the auto continuum is obviously more money. So there's a lot of companies out there who will use a manual welder for no other reason than it's of cost, and also they can always repurpose that welder to an actual manual, an individual that's welding, or they can take an individual's welder and hook it up to a cobot if they have to. So they have this, they can rotate these welders throughout the plant. And so I guess in a way I'd kind of answer that the same way that you would be observing those issues
with traditional automations the same way you would do it with the cobotic automation. And it's going to depend on how much hands-on your guys are with it.
Great. Thanks, everyone, for the great questions, and thanks again to our great speaker, Mitch Dupont with Universal Robots, for sharing his time and expertise today. Now that we're just about finished, I'd also like to extend special thanks to our sponsor, Universal Robots, for today's event. Please tell us how we did. The exit survey will pop up on the screen as soon as the webcast ends. Please take a moment to complete it because we use this information to improve our webcasts. On behalf of Control Engineering, Plant Engineering, CFE Media, and Technology, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.